Okay, so in your Desmos activity, it might be. I found it on my floor. I'm just gonna throw it away. Okay. We are gonna talk about what we're gonna call vertex form. Does anybody have a thought as to why this is called vertex form? Yeah, it's really easy to pick out the vertex because that's how we're moving our parabola, okay? So on that page 3 in the Desmos activity, you're messing around with those sliders for A, H, and K, okay? What happened when you moved A? Okay, so A is going to affect the width, right? Is it skinny? Is it wide? And we already knew that, right? Now, what did H do? I like that, moved it on the x-axis. So it's gonna move left or right. Now here's something that some of you like weren't super crazy about, but okay. Some of you figured this out. Some of you were, I'm confused why it's going this way. Notice how our equation is x minus h. So if this was x minus 3, what way is it going? To the right. If it was x plus 3, it's going to the left, okay? So if it's that x minus h, it's feeling a little backwards from what we want, okay? What does K do? Kyron? Okay, so this is going to move it up or down, okay? So shift left or right, shift up or down, vertical stretches and shrink for the A. Okay, so what we need to be able to do is we need to be able to take a parabola in vertex form and say, hey, this is where the vertex is. Yes. X is X, stays as X. Okay. So write this down with me in this little notes portion. F of X equals X minus 2 squared plus 3. Okay, so let's talk about what these things are doing. X minus 2. Which way is that moving it? Left or right? Right. Okay. This means right 2. X minus 2 means we're going right 2. What about the plus 3? Up 3. That one goes up 3. Okay. So from our normal 0, 0 vertex for y equals x squared, okay? So we call y equals x squared the parent function, okay? We're going to move it. We're going to go right 2 and up 3. So our vertex is now at 2, 3 because we went right 2, up 3. We call this vertex form because boom, boom, we can pick out the vertex without having to do any calculations. I mean, I guess. Oh my gosh, it's so funny that you're saying that. What? Okay. Write this one down and write down where you think the vertex is. Ready, set, go. I know you think you sound cool, but really you're just annoying. Check in with your elbow partner to see if they agree. Eli got it wrong, or you got it wrong? All right. Ellery, where do you have your vertex? Okay. Ellery wrote -4, -3. Noah, why did she say -4? Okay, this is x minus h. So since it's x plus 4, we are moving to the left 4. Okay. Henry, where'd she get the -3 from?
The -3 in the equation.
Okay, we're moving down 3 because of the -3 in the equation. Okay, how do you feel about this, people? Feeling pretty good? Okay. So let's come down to number 5 and number, well, let's talk about number 5. Gabe, where's the vertex in number 5? Ooh, 2, 0. Why the 0? Where's the 0?
It's because there's nothing there.
There's not like a plus a number, so it didn't move up. Okay. Allison, tell me about that 5. How does that 5 affect our parabola?
It makes it wider.
Which one? Yeah, wider or skinnier, which one? Okay, so this 5 is making our graph skinnier. Okay, our vertex is at 2, 0. Do we need to graph this to know where our axis of symmetry is? Okay, where is it? Oh, thank you for saying x equals 2. This is honestly my favorite way to graph parabolas because I feel like it's not as much work when it's already in vertex form. Okay. All right. So I want you to go to the top of the next page. I want you to go to number 7 and 8. I want you to give me on both of them the vertex, the axis of symmetry, and I want you to tell me if the shape is affected at all.
Does the -a affect what's in the parentheses?
The -a does not affect what's inside the parentheses, but it affects the shape. Okay.
So it's still really good. I'm going to -1.
Yes, it's still moving right.
Our charts in the middle, like x equals something, so it's like x equals 5, just plug in 5 there.
Yeah. Yep.
If we have a vertex, no, so when I say the shape, I want you to tell me like it's upside down. So this is like, here's our vertex, and it's upside down.
You okay, DJ? Yeah. Reese, where's our vertex for number 7? 1, 4. Right 1 and up 4. Kari, is the shape, or what's the axis of symmetry? X equals 1. Kyron, is our shape affected? Wider. And I'm going to say reflected because it's less to right. Okay. Eli, why did he say it's reflected? What told him that? The negative in front of the 1/2. Okay. Ian, why did he say that it's wider?
Because the A is 1/2.
Because the A is 1/2. That's less than 1. Okay. Harry, what's our vertex for number 8? -1, -5. Connor, what's our axis of symmetry?
-1.
Half credit. X equals -1. And then Cassie, is there anything different about the shape of our graph? It's reflected. We know it's upside down because of that negative. Okay. So let's talk about how wonderful these are to graph. Let's graph number 9. You know what? I'm going to change my mind. I want you to just come down here. We're going to just cross this guy out right here on number 11, and we're going to graph just that number 11. Okay. Okay. So I'm going to make an XY chart. And what coordinate do we like in the middle of our chart? No. No.
-1.
The what? We want our vertex in the middle, people.
Oh.
-1. -1. So our vertex is at -1, -1. We know that. There's our vertex. Okay.
Oh, so we just plug in for X and then look at that.
Yeah. So then we know that this is going to be skinnier, correct? All right. So when I plug in to the left, I pick -2. To the right, I pick 0. If we have our vertex correct, both X is 0 and X is -2 should give us the same Y value because we have that symmetry. Okay. So let's plug 0 in for X. What is 0 plus 1?
1.
Squared. 1 times 3 minus 1. Woo! That was something. Let's just make sure that we get the same thing when we plug in -1.
-1?
And by -1, I mean -2. What's -2 plus 1?
1. -1.
Squared. 1 times 3.
3.
Plus 1. Minus 1. Ah! Some of you are being robots, right? Okay. Now, what number should we pick next?
-3.
And 1. Go on the other side. Okay. It's 11. How am I supposed to what? I don't think I have enough room for 11.
Yeah, it's 11.
Do you need me to go through how they got 11? One plus 1 is 2. 2 squared is 4. 4 times 3 is 12. Minus 1 gets us 11. Mhm. Okay, now Brooks, you found a cool little trick. So Brooks knew that normally we would have points here, right? But since we have an A of 3, he knew that instead of going just up 1, we would have to go up 3. You see that? Has anybody else made that observation?
Slow is different.
Did I call it slope? No. It works for that first point. What?
He said, don't you just do it normal?
What do you mean? What's normal? Okay. He just made an observation that that's been happening. If we have like this, okay, what's happening is this number is taking your y coordinates and stretching them by that much. So where we normally would be like at a y of 1, it's stretching it to a y of 3. If it was 5, it'd be stretching it to a y of 5.
Should you do that? The first one?
With the first one. So that can be kind of like a double check for you. Okay. If you're plugging these in. Okay. All right. I really don't think that I'm trying to say. Let's graph number 10 together and then I'll give you your homework, okay? Not today, but tomorrow.
Is it gonna be tomorrow?
No. And we might even go outside tomorrow for something. Really? Really?
What is that? Oh,
Maybe a little math aerobics.
what the heck is a math aerobics?
Obstacle action.
Oh, calisthenics.
I
can do it.
I'll bring the.
All right. Where's our vertex?
4, 6, 4.
6, 4 sound better?
Yep.
Noah, which direction is this opening? Yeah. How do you know?
That's a negative.
Okay. Also, it's a 1/4. So what does that mean? It's gonna be wide. Okay. All right. So what number should we plug in here?
10 and 4. Or 10 and 2.
Okay. So I would not pick 7 and 5. Let's just talk about why I don't want to pick 7 and 5. Because we're gonna get a fraction, right? So instead of going just like 1 next door, how about we go 2 next door? That way, when we plug that in, we'll have a nicer number to multiply by the 1/4. Do you see what I mean there? If you plug in 5 and 7, is it gonna be bad? No, you're just gonna get a decimal. Okay. Ellery, are you okay with that? Okay, well, your face was thinking about something. Okay, so what happens when we plug in 8?
-1 plus 3.
Positive 3?
Not when I got.
But you got 5.
I thought you could use the slope. The negative 1. The negative 1.
I did not say so. Okay,
I did it with the 4. You get negative. Oh, wait.
you get -2, squared is 4. Okay, so Allison plugged in 4 and got 3. Okay. What should we plug in next? 10 and 2? You could do that. When we plug in 2 and 10, we get 0. I'll just let you know.